Hello. Okay, so good afternoon, everyone, professors and oh, okay, thank you. Yeah, I'm Vincent from National University of Singapore. Leading a team of scholars in NUS, working on the field of robotic scanning and scan to beam and computational optimization, using the digital twin to support building plannings or urban level planning. So today is an honor to be here and sharing our research on automated SBU 3D reconstruction using quadruped robot and 3D LiDAR sensor. So I'll be presenting the background first, and then the methodology followed by our experimental result. So some background first. I think nowadays there's a lot of buildings and infrastructures, and especially those aging infrastructures have facing the challenges of maintenance, operational management. So condition monitoring, inspection, and assessment for these architectural, engineering, and construction projects so require precise data regarding their as-built conditions. And in the past, we have using the terrestrial laser scanner, right, to scan the built environment, capture the precise data from the built asset. And nowadays, we see the community has interest in developing and researching new automated and mobile scanning approach, right? So which they would use the automation platform, which you can see at the bottom side of the figures. So the unmanned ground vehicles and the quadruped robots carry the terrestrial laser scanner or LiDAR camera system to capture the building or site as-built conditions. So this would provide better productivity in the as-built data captures, and it also provide values for smart digital city reconstruction or 3D reconstructions. So there are some research they are publishing in the top journal like Automation in Construction or AEI on this agenda. So for example, the some research on using unmanned airborne vehicles, UAV, and the mobile robots carry the scanner and scanning bridge and then construction site, etc. And there's some pioneer works, I think from Professor King and his team on using robots to scan the scaffolding system on the construction site. But we also see some gaps in the existing literatures, okay, regarding the integration of point cloud data quality and the completeness over the 3D scanning process. And then we could factor in these more comprehensively in the early scan planning. And this one was substantially optimizing the robotic control, navigations, and towards a more productive and efficient scanning process. So in fact, our team has also done some previous relevant work. We are using the quadruped robots, carry a solid state LiDAR scanner and doing indoor scanning, which we're trying to formulate the scanning, the coverage, and also the data quality into the early phase scan planning. So the beauty of using this quadruped robot is that they can have a high mobility. They can twirl left and right, head up and down, so that they could actually enable the solid state LiDAR scanner to have a more scanning range for the indoor environment and enable the dense 3D reconstructions. But for today's research, today's paper, we actually takes out another type of LiDAR, which is a 3D LiDAR sensor that will mount on the quadruped robots. We want to test out whether the new LiDAR system can enable a more convenient or high quality data captures. So in this paper, we present this quadruped robot and carry with Oyster, okay, 3D LiDAR sensor. And then it was bundled with our scan planning algorithm to carry out indoor scanning, automated navigation, and reality captures. So these are the experimental setup, all right? So as you can see on the upper side of the figures, we actually using our scanning algorithm developed previously. So that algorithm holistically factor in the coverage of the scanning 3D scenes and also the data quality. And it would tell where precisely the robot should be traveled around in the built environment so that they can capture the satisfactory level of point cloud data or imagery data. And with that scan planning system, then it will carry forward the scanning position into the quadruped robots. So the quadruped robot would connect it with two sets of LiDAR. One is the 2D LiDAR sensor. It's actually used for the robotic indoor navigations. It will actually help the robot to perceive the objects, including human or the static obstacles, okay? So for it to travel around the environment, the cluttered environment. And we also have another is the 3D LiDAR sensor, and then it will be used to capture the point cloud data, and then we bundled it with the the LiDAR slump algorithm to reconstruct the 3D scenes. So in our method, we also take out two scenarios. One is called the couple reconstruction and decoupled 3D reconstruction. The decoupled reconstruction is that we would use 2D LiDAR and 3D LiDAR separately. 2D LiDAR doing its on drop for the navigation, and 3D LiDAR would doing the 3D point cloud capture. Then for the couple reconstruction scenario, we're trying to mute the 2D LiDAR. We're purely using the 3D LiDAR for both the navigation and doing the 3D reconstruction, and see if we could save the cost of another LiDAR. So here is actually some quick experimental result. We take out the experiments in our educational building in NUS campus within our center. So you can see the robots, they put the scanner and then walking around automatically, okay, doing the data captures. So during our testing, we actually have the occupants walking around, and then so the robotic dog will automatically store or pass by those human or the static obstacles, okay, in order to avoid clash with the humans for safety operation of the robot. And while they navigate around the scan position, they would keep concurrently captures the point cloud and reconstruct the 3D scenes. So some finding from our study, we take out and then they scan a very large areas of the entire buildings. And we can see that the point cloud visually by human inspection looks quite decent. They can cover most of the data, okay, they are required in the built environment. And we also see some interesting finding. Previously, we take out two scenarios. One is the couple, and the other is the decoupled reconstruction. We find out that the decoupled reconstruction would be better. Okay, it's better to leave the 2D LiDAR for navigation and 3D LiDAR for capture the point cloud. When we bundle the two tasks together and rely on the 3D LiDAR, and we find out that when they reconstruct the 2D map using the odometry information from the 3D LiDAR is actually downgrade the quality of the 2D map, and this one would impact the navigation indoor and the 3D captures. And we also take out the result by comparing the mobile laser scan with terrestrial laser scan. So we're supposedly using terrestrial laser scan, the survey scanner, as a benchmark, right? So as a ground truth. So we can see that the mobile scanning method has some improvement in the coverage because the scanner can actually, the mobile scanning can actually working around quite fast. But we also see there are some discrepancy in the accuracy of the point cloud. This can probably due to the limitation of the equipment. Yeah. So for the interest of time, this one would be the conclusion, and we take out the method, and in the future, we will continually expand a more comprehensive scanning method together with our robotic scanning platform. Yeah. Thank you. So sorry for the overrun. Thanks.